Hi everyone, thank you very much. Today you are going to start day 2 challenge. Really great. You have to appreciate yourself because everyone accept every challenge, but fewer people contribute. That fewer people you are. So day 2 challenge, just appreciate yourself. You are the great. Now, just I say simple music, just observe ourselves. It's very important because of the learning very important. But you have to observe yourself, most important thing. 80%, once you observe yourself, automatically learning and implementation is a really great. Okay. Okay, I hope you're listening the music. Close your eyes, take your right hand, put on your heart. Feel yourself, why you are joining today. Everything ask yourself why. Keep smile on your face. Observe your breath. Inhale through the nostril. Inhale through, exhale through the mouth. Just to make it relax. Just you have to do it 3 times. Inhale through the nostril, exhale through the mouth. Same pattern. Now normal breathing. Inhale through the nostril, exhale through the nostril. Just observe what are the identity day 1 I have said. Keep smile on our face. Just believe in yourself. You're working for 2028 vision. Just to visualize yourself. You have 100 clients 2028. Everyone waiting for giving money for you. You have to work on future self. You are doing energy auditing 2028. So this year 2026, you're building the certification, building the confident. 2027, you're doing the auditing, building the branding and network. 2028, you serve 100 clients. Just visualize all the process. During the time, you feel it normal breathing. You feel I'm always best. I am the best. Now rub your hand. Forcefully, very heat. You feel the heat. Put on your face, eyes, and see your palm. with smile. Open your eyes with smile. Just one word, you have say yourself, what is your feeling? How you feel about yourself, about the community, about the connection. It's really great. You feel it, that energy. Okay. Next step, you have to change your identity. It's very, very important. So I will share the screen. Can you see the screen clearly? I hope. This is affirmation. It's a great affirmation. It's always your read. I am a confident and capable energy auditor. Every day I grow in knowledge, take action, and make a difference in the world. I am committed to sustainability, success, and creating a better future. This is one of the affirmation. Always you feel it. Every day, your day. God is always with me. You take left hand, always say it. God is always with me. Today is my day. I am a winner. I am the best. I can do it. You change your identity, powerful image. You have to create yourself in front of the mirror. Every day, in front of the mirror, you have, whenever see your face, you are the great leader. So leader always doing better, best, helping other, not blaming other. It's one of the things you have to always understand. So 2028, your vision, you are working for 100 clients for one crore project, whatever, helping for company, or you are doing oneself, whatever thing, you have to believe it yourself. It's a process. 2026, 2027, 2020. This is a wonderful process. You are go through it one by one. You have the 100% responsibility to attend the live class, go to recording, focus on the class. You have to always remember, you raise your standard. Quality is important than quantity. Your focus, 20% learning, 80% implementation. So whatever you are doing is at 20%. You have to understand 80% what is remaining thing. So you do the own type calculation, 1 mark, and you have to do the repeated test and the connection with the people. Group discussion very, very important. Every day 1% improvement, the mindset. You create opportunity in work and life. Your decision, your destiny. So always final thought after 68 years. What is your final? Love, happiness, fulfillment. Simple. So your mission. Simply understand you have to leverage 1 million lives. So purpose, awareness, and impact. You are creating the purpose awareness, not just technical skill. It's one of the thing. So simple 21 challenge you have to accept it. So if you not attend live session or complete session within 24 hours, today not possible attend, but tomorrow same time before you have to complete it, this session. Otherwise, you have to pay 50 rupees per day. If you not miss a couple of days, 100 days penalty. If not complete weekly, you have to pay 250 rupees. Very important. It's not a mandatory. It's not a mandatory. It's a personal commitment and your discipline and a self-challenge to grow. So this one I have followed. So I consistently follow this one. So reward. Once you complete 21 days, attend all the sessions regularly, score 70 plus mark, then you get the reward, 500 rupees. So don't feel about the money, feel about the reward. Same thing, you are receiving the 5,000 or receiving the 5 lakh rupees, how you feel? Same, like if you receive the 5 lakh rupees, 21 days, you receive the 5 lakh rupees, how you work on this one? Simply you think it, everything mindset. So after 20 days, you receiving 5 lakh rupees. Like that mindset create, you have to work on. So first two participant, very, very important. So today's session, we are go through it. Simple one. It's very, very most powerful. So O2. It's a equation, the combustion equation and O2 calculation. I will share the screen. You can easily understand. Observe it quickly. This is very important. So first day we are going to the combustion equation, O2 calculation, theoretical air, and personal O2 calculation, CO2 calculation. It will take 1.1 hour 20 minutes. Are you clear? It will take 1 hour 20 minutes. So full focus on O2 calculation. From the O2 calculation, how to calculate theoretically. You have to form the equation, O2 calculation, and theoretically. It's a very, very important session. You have to attend clearly and continue the process. Then end of the session, I will ask some question. You have to answer. Thank you. Thank you very much. So end of the question. So end of the session, you have to share your review. It's very, very important. You have to share your review. Okay. In chapter 1, second session, this is a very important second session, calculation. So I will share the screen. I will ask one by one. You have to explain. This is a boiler. The boiler. I'm giving the fuel. I have to give the air also. I have to give the air also, no? Air. This air, two types available. So air contain O2, N2. This is okay? O2, N2, no? Air. So two type of air available. Theoretical air, excess air. Basically. Theoretical air, excess air. This year we can say primary air, secondary air. Based on our requirement, we can. Basically, this is a primary air plus secondary air. So theoretical air, excess air. I will write it clearly. This is basically you have to understand. Next one's water. In boiler, we have to feed the water for heating. So that is a feed water. So feed water. If feed water giving means boiler burning, inside the everything, tube oil, everything available, oil tube available, water tube available, you are burning. What will produce here? Steam. Here producing steam. This is producing steam. Steam. This is a water producing steam. This is one input, another output. If I burning air and fuel, what is the output coming? What is the output? It will come. Any idea what is the output? Any idea?
Complete combustion, CO2 will come.
Yes,
Incomplete combustion, CO will.
This is going to flue gas.
Flue gas.
Flue gas. This is a flue gas. This is a flue gas. In Tamil time, I add a diagram here because place is very less. So I add here. There is no difference. Same concept. Here you have to mark it. How many input, how many output? How many input, how many output?
Input is a fuel, air.
Fuel plus air. This is a input one section. This is a input one section. What is the output for fuel and air mixing? What is the output coming for fuel? This one?
Flue gas.
This is the output. Yes, this is output one. What is the input? Another input?
Water.
Water. This is a input 2. What is the output? This is output.
Steam.
This is output 2. The simple concept. So mango available plus water. Both are mixing with the mixer. Mixer na? Mixing.
थोड़ा milk and sugar भी add कर दीजिए.
Yes. Water plus, yes, water mixing plus milk, yes, sugar. Nice. Mixer plus sugar. So it producing the juice, mango juice. Mango juice, no? Plus, what will happen? Heat energy coming. Heat energy always available, no? Simply calculated, this is only as a mass. The kg of mango mixed with kg of water, adding the energy, heat energy, mixing, it produces mango juice plus heat energy. This is a heat balance, weight balance, both available here. Heat balance, weight balance. So what is the heat? Using the mixer. Mixing you are using means what will happen? Add heat also adding now. What are the mass? Simply you have to separate one. Mango. Mango is a kg of mango, water. Plus sugar. So whatever coming is a raw kg balance, mass balance. It is coming mango juice. It's a mango juice is a mass balance. I'm separating two equations. It's a mass balance. Another one is a heat balance. Only heat. So heat balance, what is the mixer? I am using mixie. I am using a mixie. What will producing? It is producing heat. Heat energy in juice. Okay. Both are equal, no? Something loss is always available. Something loss always available. So we can find out this loss in here. Some unaccounted losses also available. So, but flue gas for boiler, you have to calculate everything. This output very important. Flue gas output very important. Flue gas output, this output very, very important. This output very, very important. So this output, what are the content available? Fuel, what are the component available here? Fuel. In fuel, what are the component available? Basically, fuel, carbon,
coal,
carbon,
hydrogen, oxygen,
moisture,
and nitrogen,
ash content,
gas content, everything. Basically, and sulfur. Okay, this is available now. This we are taking furnace side. So what will happen? Furnace oil mixed with the air, we are firing. We are using the firing component. Firing inside happen. Feed water get absorb the heat from this boiler and is converted to steam. That is this function completed. This chapter going to discuss chapter 2, chapter 3. First chapter, what we discuss, this flue gas analysis.
yes.
What is it? Flue gas analysis. So flue gas analysis, what is the purpose of flue gas analysis? Very important. Why we are analyzing flue gas analysis? What is the purpose of flue gas analysis? What is the purpose? Main purpose. Increase the efficiency in combustion. 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 Incre Increase compression. Very important. Complete the compression properly. Increase foot compression. What are the parameters we have to analyze? So, first you have to understand in fuel air, this is inside now. Fuel air. We are giving kg or liter. This is a liter. Air also giving. In volumetric flow, we are giving it convert to kg. So, input side always understand weight by weight ratio. Input side. This is input side. This is input side. Always is very important one mark. Always weight by weight. We are putting weight by weight ratio. Understand? How much weight? How much? If you are giving the air 100%, 21% is a 21%. What is this? 23% what is available? 23% O2 available. 77% 97 available. It's a weight by weight calculation for air. If burning, after burning, it is coming outside. Here is a flue gas. So flue gas, how to calculate this one? How to calculate this one? Any idea? How they are calculating? Volume basis. It is a weight basis. This 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 is a volume basis. So volume basis, what are things you have to analyze? Volume basis. Volume basis V by V. Percentage of volume by volume. Okay. So volume by volume is what you have to analyze. C mixed with the O2. What is the produce here?
CO2.
CO2. Okay. H2, O2 mixing, what will produce?
H2O, water. H2.
H2O. Clear? H2 water producing. Suppose you are giving the excess air. Suppose you are giving excess air. So excess air giving, what will happen? Excess air, it is producing with O2 not mixing with the fuel because it's the excess air. So O2 will come. So O2. Here, what are the data you have to analyze? It's very important. For volume by volume basis, you have to analyze percentage of O2, percentage of carbon dioxide. It's a volume by volume analysis. Here is a kg per weight per ratio. Here is output volume. Why volume? Because in chimney, it's always mixing with all the components, carbon dioxide, H2O, O2. So we are there converting in the volume basis. Next section I will explain. Still now you understand all the concept. Why boiler? We are using fuel with the air mixing, feed water, steam output. Then convert to CO2, H2O2. For example, this is a mango, na? Mango water. Everything is a mango is a weight basis, na? Everything is a weight basis. This is a weight basis. Simply you have to understand this is a weight basis. This is a volume, na? It is converted to liter. Converting is occupy any places, then it converting volume basis. This is a mixing. Same concept. What do you understand now? Boiler input. Input of boiler. What is the volume basis? or weight basis input? Fuel and air.
Weight basis.
Weight basis calculation. Output flue gas.
Volume basis.
Volume basis. Okay. Air, how much contain, how much percentage contain weight basis O2, N2? This is the next one.
O2 is 23%.
Yes. For weight by weight, O2 23%, N2
78%.
77%. It is very important. Don't forget this one. Still have any doubt? Now clear this point, everything. Why we are analyzing this calculation, everything. Next one, we have to understand mole molecular weight. What is a mole? What is a molecular weight? Mole. It's orange. Orange or mango. So okay, I keep it mango. The mango is a mango. How many mango available here? Mango. This is a mango. One number available now.
Yes.
This is called, what is this called? One number. Quantity.
One.
So only quantity. So one number available. Next is a molecular weight. Molecular weight. So molecular weight. Mango weight, how much? I will give you suppose 7 kg. Molecular weight, mango weight. Mango weight. So 4 kg like this. So 4 kg. This is a molecular weight. Clear? Why we are doing this one means, if you are here missing fuel, air, everything mixing is coming to out, carbon dioxide, sulfur dioxide, everything coming. Here you have to find out how much mole available. Here you have to find out how much mole. It's a very important concept. How to find out? Simply, each mango 4 kg, one bundle or one box. One box equal to 120 kg. Okay, 120 kg. Now, how much mango available? Is it possible to calculate? How much mango available?
30 mangoes.
Mango.
Okay.
How much mango available?
Total box quantity divided by each mango weight.
Yes, 120 divided by
4.
kg of mango per kg. How much?
30.
39.
30.
Oh,
30.
30 numbers. Very important. 30 numbers. So 30 numbers, what is the meaning of 30 numbers? As per our basic concept calculation, this is called mole. This is called mole. This is molecular weight. is a molecular weight. Clear? Now clear all the
Yes.
concept, molecular weight. Now as per the scientific calculation, as per the science, we have to do the calculation. So C is a carbon. 1C, only 1C. It's a 1 mole now. C is a 1 mole. This is a mole. Mole, molecular weight. So molecular weight. Tell me C how much?
12 grams.
12. This is I'm taking everything for 1 kg of fuel, not gram. For one very important, our calculation based on the kg. So you have to take it kg only for 1 kg. We are taking for kg. Okay, for kg level. For kg. So C means it will come, for kg means it will come 12 kg.
Okay. 12 kg.
For O2,
32 grams.
32. So we are taking for kg. H2,
Stage 2.
2. Sulfur,
32.
sulfur 32. Okay. Next, we are doing the calculation. What is the basic calculation? 3 calculations always you have to understand. Basic 3 calculation, 3 equations. Three equations. So C 1C plus 1O2 CO2. This is a position. What is this C, CO2, CO2? Everything mole. It's a mole, no?
Yes.
It's a mole. Next, you have to add a molecular weight. What is the molecular weight? Carbon 12.
12.
O2 how much? 32.
42.
How much coming? 64.
44.
44.
Sorry. 44. This is a molecular weight. This is a 44. This is a molecular weight. This is a molecular weight. This is a molecular weight. Okay. This is a 12 kg. Na? 12 kg carbon need 32 kg. It producing the 44 kg of carbon dioxide. Are you understand? 12 kg of carbon. This equation. Only I am writing one equation. You can understand remaining. What are the basic calculation? The same concept every calculation. 12 kg of carbon C plus 32 kg of O2, it is producing 44 kg of what producing?
CO2.
CO2. Once you understand this equation, you can do anything. So 12 kg of carbon act with 32 kg of O2, 44 kg of carbon dioxide. Now 1 kg of carbon, how much producing for calculation for calculation for 1 kg carbon. Very important. So for 1 kg of how much O2 required?
44 by 12.
You understand this is input? You understand? Na? This is input. This is input. This is output. Okay? This is output. I will write clearly. This is input. This is a output. Okay, for 1 kg carbon, next one is for 1 kg carbon. For 1 kg C, how much O2? Okay, how much O2? Kg of O2, very important. How much kg of O2? O2, and produce how much kg of carbon dioxide? And produce means output. It's output. How much kg of O2? So carbon dioxide. So how to calculate this one? We are calculating for 12 kg now. We are calculating for 12 kg. Okay, clear? So you have to divide by 12 now for 1 kg. So 12 divided by 12 for 1 kg C. So what do you have to do? 12 divided by 12. So C plus 32 divided by 12. O2. Now 44 divided by 12. CO2. Now tell me the value. How much?
So 2.66 kg of O2.
1 carbon act with, here tell me sir,
2.66.
6 after 6 coming?
6.
6. Yes sir, 6, 7. 6, 7. O2.
Produce 3.67 kg of O2. Sorry, CO2.
CO2. This everything kg. 1 kg is a kg. Clear? So 1 kg of carbon producing 2.67 O2, 3.167 carbon dioxide.
That is a 3.66.
So 3.66, sir.
Yes,
Okay,
yes.
3.67.
3.66.
Okay, full form. So 67 carbon dioxide. Suppose in question, how they are giving? They are giving the percentage of carbon only. So 86% means how much kg?
0.86.
0.8 kg. Still now you understand, for 1 kg of carbon required 2.6 and O2 is standard. This is standard, no change. This equation is a standard. Next you have to calculate for
H2.
okay, next you have to calculate for next one. Same H2O. H2 plus O2 H2O. So what is the molecular weight H2O? 2 plus 32 equal to, we have to equal this one. H2, H2, O2 means here you have to add 2.
First to balance process.
Yes, 2. Here is a 2. Here is a 4. Here is a 4. Totally how much coming? 36.
Excuse me, sir. Why we have multiplied by 2?
Yes, example, sir. Here you have to balance this one. Now you see H2 plus O2. How much H2 available, sir? Here. How much H2 available? H2 available, sir? It's okay.
Yes.
2 H2 available. O, how much O available? Only
Single
1 O
molecule.
available. Here is a single, here double O available, here is single O available. So you have
Okay.
to multiply with 2. So now what you can see, O2 is a okay, equal. Input equal to output. This is very important. Can you understand now, sir? Input
Yes.
equal to O2. Okay. Now O2 balance okay. Now H2 is a 4, na? 2 into 2.
Yes.
You have to balance so that here you have to add 2. It's a good questions. Now what is the 4, 32, 36? What is the number, sir? What is the meaning of 4? What is the meaning of 32? What is the meaning of 36?
4 kg of H2 can mix with
4
32 kg of O2 and it will give 36 kgs of H2O.
Okay, next what you have to do for 1 kg? Same equation for 1 kg. So what we have to do? 4 divided by 4, 32 divided by 4, so 36 divided by 4. What is the answer?
8.
9.
8
9,
O2.
9 is equal to 9.
8 O2 and then 9 H2.
1 kg of
1
H2
kg of H2
mixed
will
with
mix with 8
9
kg of
O2,
8
8
kg of
kg of
8
8
kgs of
kg
8 kg of
O2.
O2.
We can
O2.
produce 9 kgs of H2.
9 kg of H2. Here you have to understand 9H2O. Before we have seen one equation, moisture content.
Calorific
Cross
value.
caloric, you have to calculate, na?
Yes.
9H2.
Yes, this is a 9H2. Here you see, na? 9H2. This is 9H2. Moisture directly coming. So this is standard. How much O2 required is 1 mark. For producing 9 kg of O2, H2O, how much kg of O2 required? 9 kg of H2. 9 kg of water if you produce, mean how much kg of O2 required?
8 kgs of
8
O2.
kg. It's very important. 1 mark. Next is a sulfur. For sulfur. This is for 1 kg, everything. I am not, this is for kg. We are calculating for kg. We are not calculating for percentage of carbon dioxide. Only this calculation for you have to understand basic one. For sulfur. S plus O2. What is producing? SO2. How much kg? 1 S mole, 1 mole. This is a mole.
32 kgs.
32 plus 32.
Plus 32.
How much producing? 64.
64.
For 1 kg?
For 1 kg of O2.
32 divided by
2 kg
32.
of
Okay. Plus
1
32
kg of
divided by
sulfur,
32 equal
1
to
kg of oxygen,
60.
2 kgs of SO2.
Okay.
1 kg of sulfur, 1 kg of oxygen.
Two kg of sulfur 2. Okay. Here you have to understand mole is very important. So sulfur 2 is a mole, na? Sulfur 2. This is a mole. This is very important. This is a mole. Every equation already I have mentioned, na? This is also mole. This is also mole. What is the weight this mole?
44.
This is
44.
molecular weight. I am converting molecular weight. How much molecular weight? 44, na? 44 kg. Okay. I am always we are calculating kg. So this is also mole, na?
Yeah.
This is a mole. What is the molecular weight?
54.
Molecular weight 64. Same H2 also mole, na? 1 H2. This is a mole. This convert to one product. Simple. Mango plus water. Mango is different. 1 kg. Water is a kg. Both mixing. We converting mango juice. So juice, one product. Same mole. This is a mole. So molecular weight how much? This is a
36.
how much? 36. How much mole? Very important. How much mole? How much mole? This is only 1 mole. Understand now? This is only 1 mole. How much mole? 1.
1.
1 number. This is also how much? 1 mole.
2 moles. Sorry.
It's a combine. Equation
Twice.
complete. This
It's
equation
a
complete.
twice. Okay.
SO2 how much mole? 1 mole. Now you understand? This is a convert to one product. Simple. S plus exactly S H2 mixed with O2 is converting H2O, water.
Sir, for this, this is a twice H2O. So because of if we are adding 1/2 O2, that equation is also mole in a 1 mole.
Yes, basically this is H2O we are taking 2 mole. Sorry, this is 2 mole.
Yes, sir. Because
Yes,
of
yes.
if you add
Yes.
if you add 1/2 O2, that's equal to H2.
Yes, we are converting, we are changing 2H2. Okay, this is a 2 mole. Here we are, if
Yes.
you are adding is a half O2 means it's okay.
Yes, sir.
Sorry, here half O2 means clear. Okay, super, sir, super, sir. This is a 2 mole. Now
Yes.
understand? This is SO2, this is
Yes,
a
sir.
carbon dioxide. Next one, carbon monoxide. It's a partial conversion.
Yes.
For carbon monoxide. So what is the equation for carbon monoxide? C plus O2. It's converting CO. Carbon monoxide na? Plus heat. What you have to add? Half O2. Very important. Half O2. Otherwise, it will convert to 2 mole. This is how much mole? This one? This is how much mole?
1 mole.
Mole. Number of mole? 1. What is the molecular weight? What is the molecular weight?
60.
20 na, sir.
12 plus 60, 28.
28.
Molecular weight?
28.
C is a 12.
28.
28. 28 kg.
28 kg.
Now clear? What is the mole? What is the molecular weight? Now clear all
Yes,
the
sir.
concept?
Yes, sir.
Yes, sir.
So this equation we are converting chemical reaction with the molecular weight, how much percentage. Simply we have to calculate everything. Okay, this section I will record switch off. Next section we are going to analyzing how to conversion working. Basic conversion. Before the calculation, you have to understand the conversion, very important.
Yes, sir.
Next is a very important part. Next is a very important part. It's a conversion. The conversion basic concept before after. What is the conversion before after? Before after. You have to basically understand, then deeply calculation that you have to understand. For juice, initial condition, I am writing very shortcut. Mango plus juice plus water plus water. What do you make? If you are mixing using water, juice making, na? First time, before you are, this is everything calculating. After making juice, you are adding extra, na? What is the purpose of extra? You finishing the juice perfectly. So after what you have to do, mango, so already available juice. So that means juice means not finished juice. Clear? Solid level, little bit solid. Okay. So not finished juice. Juice mixing. What you have to add? Extra water. You are adding extra water, na? Extra water. What will happen? Extra water. Good combination. Okay. Good or best one. Juice. Good juice. For drinkable. Now clear? How you check this? Mixing proper, not proper. How you check this one? How you check? Mixing proper or not proper?
Leftover content.
Balancing.
If you're mixing with the mixie, then remove the mix jar, open door, then you check the output, na?
Yes.
Same concept. What is the hint here? How you check not finished? As per our standard, it's output. Simple.
Yes.
How you check not proper mixing? Juice output, simple. Same concept we are using. What is the juice output? Now clear, this is juice output. Same. What is output for boiler? This concept understand?
Yes.
Okay. Juice output. Here juice output, what is available? Mango plus water, mixing everything, juice, final juice. Here is a extra water. What is extra water? Same, we have to add air, extra air.
Excess air.
Excess air. This is a calculate air. So we have to do for next level, for our standard. For our this you have understand. Now we are going to for this one. So before burning, after burning. Before boiler, burn, after. Same section we have to take. Only I take only one input, one output. Not take multiple, only I take only. This is a boiler. It's a boiler. First section I give the fuel. Fuel I give in a fuel. Here is I give the air. This air What is the air? This one. Theoretical air calculation, very important. This is a theoretical air. TA. TA means theoretical air. TA means another name also available. This is theoretical air. Another name is a stoichiometric air. That time we will check it everything. Now what will happen? Output, simply output coming flue gas. So flue gas. Okay. So exactly I am giving the fuel plus theoretical air. What will come output? Air, what are the quantity available? O2, N2. Okay. N2 not mixing. So N2 coming here. Next, fuel have carbon, hydrogen, sulfur. Okay. Fuel have carbon, hydrogen, sulfur. What will come here? Carbon, hydrogen, sulfur. What will come output? Tell me that quickly.
Carbon.
The heat energy always coming, no issue. Heat energy always mixing, heat energy produced. Then output, what is the output coming for flue gas? What are the output?
Sulfur.
Moisture.
Moisture.
Proper equation. We are calculating everything properly with the equation based on the output.
CO2 will come.
It's very important. This is output. Flue gas means output. Clear? What is this? What is this?
Flue gas output.
This is output. So what is the output?
CO2.
CO2. Okay.
Moisture content.
Sulfur dioxide, SO4.
SO2. Simple. Moisture H2 coming, H2O coming. H2O coming. Nitrogen, CO2, SO2, H2O coming. After what you have to do, if you're burning everything, now check the percentage of carbon dioxide, everything you are checking. Na? Here, what you measured? Here is a volume basis. What is the volume basis measure? Here, measuring, very important. Measure. Output measure. It's very, very important. I am shortcut. Output measure, volume basis. What are the details you are measuring for XSR calculation? Percentage of carbon dioxide. What measuring? Percentage of carbon dioxide. How to calculate the percentage of carbon dioxide? Number of mole. Number of mole. Very important. Number of mole of carbon dioxide divided by mole of sulfur dioxide, everything. How to calculate percentage of carbon dioxide? Number of mole carbon dioxide divided by total mole. Total mole means what include? SO2 plus CO2
plus N2
plus N2
plus H2.
H2O not coming, sir.
Right.
Is water vapor not including here.
We are
Only
calculating.
N2, CO2, sulfur dioxide.
Okay.
The gas pump. This is coming for gas. We are analyzing for this main purpose for adding for XSR. This is everything. Okay. What is this? This is a theoretical. We are doing everything for theoretical calculation. What are you doing? Everything theoretical calculation. What is the calculation? This actually, as per the equation, they are calculating. This much of carbon dioxide coming, this much of SO2 coming, this much of N2. This is a theoretical calculation. So after burning, boiler burning, what will happen?
Bottom ash and top ash.
They have to calculate XSR. with as per the theoretical air. Same, this is a boiler. Same air, fuel. This is air. Here is a flue gas. Flue gas. Now what will happen? They are checking carbon dioxide. Then the completion not properly done. They have to add excess air. So what is the air? Here is what is air available? Two type available. What is the air available? Theoretical air.
Theoretical and
excess
excess.
Okay, theoretical excess are both the calculation for actual air supply. This both include what is the name? Actual air supply. TA plus EA. This is air supply, very important. So both are mixing. What is coming output? Flue gas output. So whatever coming, you have to do it N2. Okay. N2 coming, SO2 coming, then carbon dioxide coming now. Carbon dioxide coming. As per the, this is as per theoretical air. This is for as per the theoretical air. All you understand? This is a theoretical air. TA. Now we are adding extra air. So extra air means what will come extra air? Plus. Whatever excess air O2 available, directly coming in O2. And the N2 also coming in. Are you understand this point? I am adding extra air. This is very important. Excess air main purpose, I analyze the theoretical carbon dioxide, how much volume available. As per the calculation, I am adding the excess air. So how much excess air? What are the quantity coming excess air? O2 coming and the N2 coming now. This is the excess air. This point you understand? Both plus. This is the excess air. Any doubt? This is the excess air. So excess air plus both combined, one equation formation, total. It is a combined, totally you have to calculate. So both combined, what will happen? Output N2, SO2, carbon dioxide, O2, then H2 also coming. H2 available, H2O coming. So this equation don't include, only focus on the these three things only, these four things only. This calculation N2, SO2, CO2, O2. Clear? Any doubt? What is any doubt for excess air, theoretical air, actual air? This is a basic concept for next calculation. Everyone understand this calculation, sir?
Yes.
Amul, sir?
Yes, sir.
Yes,
Patel,
sir.
sir?
Yes, sir.
It's
Yes, sir.
overall review for a basic calculation. So next, what you do what are the calculations we are going to do?
Calculate,
We are main focus, we are
Theoretical.
calculating theoretical air, excess air, then actual air supply. Here is very important. Theoretical air, how to calculate, excess air, how to calculate. This is a very important concept. Theoretical air, how to calculate?
There is a proximity analysis equation will be there, no, sir?
Yes. Theoretical air, how to calculate how much O2 required. How much O2 required for CO2 H2O. This is a very important point. Okay, theoretical air calculation. First, you have to calculate theoretical O2 record. From theoretical O2 record, then you have to calculate theoretical air record. It's a very important concept. So theoretical air record, very important. First, we focus on theoretical air, then we focus on the excess air. How to calculate theoretical air, TA. What is the meaning of theoretical? Simply, we can finish within 5 minutes. So theoretical air. How to calculate theoretical air? I will write it equation. How much O2 required? Step 1. How much O2? How much O2 required? For CO2. What is the next? Sulfur
SO2.
dioxide and H2O.
2 and 2.
This is the first step, na? Second step. Second step. We cannot produce exact O2. We can't produce na O2. Not possible, na? We have to separate it from air. It will take too much of cost. So second step, you have to understand, we cannot give O2 directly. Are you understand?
Yeah.
What is the third step? You understand the concept. You don't know. You cannot produce O2. So you have to calculate the air. You have to calculate theoretical air. Before, what you have to do? How much actual air supply? Actual, as per the calculation, you have to calculate actual air. Actual air. Calculate the air. So calculate the air requirement. How to calculate the air requirement? How to calculate the requirement? Air requirement. How to calculate? For weight by weight basis. So 23% O2, 77% N2. Clear? How to calculate this one? O2 air requirement as per the calculation.
Formula. As per the ultimate analysis formula.
Ultimate analysis.
Total oxygen into percentage of oxygen.
Now we have to calculate kg of air, kg of O2 requirement. Now you have calculated kg of O2 requirement. Very important. kg of O2. Very important. Now first equation we have to calculate O2. kg of O2. Now we have calculated kg of O2. From this one, you have to calculate required air. As per the calculation, air. from step 1. So what is the actually percentage? So equation percentage of O2 equal to kg of O2 divided by total air. Na? This is a formula into 100. Are you agree this formula? This is a formula, na? Are you okay this formula? This is a basic formula. How much percentage? We know already 23%. So 23%. Kg of O2, how much? As per the kg. We know kg of O2. Just write it. Then total air. We have to find out total air. As per the calculation. Now you have to find out total air. Now you take it total air. Total air equal to kg of O2 divided by 23 means 0.23. Simple, finish. Now you can calculate na? Total air. Calculated total air. This is a calculated total air. So we need to find out theoretical air. How to calculate theoretical air? TA. Theoretical air equal to calculated air as per the equation total air minus fuel always have some O2 na? Kg of O2 in fuel. In fuel. Clear? Now point is clear. Now point is clear. This one. Now you understand? What is the theoretical air? The theoretical air equal to, now you can write it here, Xn. So theoretical air equal to calculated air
Please give some
sir.
example after that. I can
one side.
understand.
Wait, important. Before we have to do, we have to calculate kg of O2 total air of this one. We have to calculate now. This is next step.
Yes.
We have to calculate the O2 requirement. Then only you have to find out next equation. Same equation, there is no different. Because O2 is a different. Air is a different. So now this equation understand calculate total air kg of O2 divided by 0.3. Now what you have to do, this is a theoretical air. So calculate, it's a theoretical air. We have to find out kg of O2 requirement. How much calculated is a kg of requirement? This is as per the equation. From outside, what is the equation you have to calculate. Now what you have to do, calculate the actual air, actual O2. Actual O2 required. This is a very important equation. Actual air required equal to, then only you have to convert. So actual air required how much? Kg of O2. Kg of O2. How much kg of O2 from step 1? Minus O2 in fuel. Kg of O2 in fuel. Now clear? In fuel always have some O2. We have to remove the O2 from that as per step 1, what we have calculated from equation. Then only you have to calculate theoretical error. Okay, then only you have to requirement error. That is called theoretical error. This is theoretical error, TA. From calculate error from actual O2 required. Very important. Actual error required. Where the calculation is available? This is a calculation. This is
Sir,
theoretical.
yes,
Actual O2 required.
hello.
Sir, one second, sir. I will complete this one, sir. Finish it.
Okay.
I will do it this one. Clear? This is the actual error requirement. As for the calculate error from the actual error required. Very important. This is theoretical error. O2 required, sorry, O2. Actual O2 required. The kg of O2 divided by total error. Same kg of O2 divided by. You have to find out theoretical error requirement. This is a final calculation. Are you understand this calculation? Otherwise, I will do it again.
Yes, understood.
Just O2, we have to calculate O2. This is the actual O2 as per the equation. You have to understand this very important, crucial point. What is the main important? You have to find out. Calculated O2 required. Okay, kg. Kg of O2 required. This is the first step. Kg of O2 required. It's very important. Huh? Second step, what you have to do? You have to find out the actual O2 requirement. The actual O2 requirement means this is very important. Actual O2 required. How to calculate the actual O2 required? Kg of O2 required. Everything kg. This also kg. How to calculate the kg of requirement? So calculate kg of O2 minus O2 present in minus, this is a minus, O2 in fuel. Okay? Are you understand this one? Third,
Yes.
you have to calculate theoretical error. Third one, you have to find out theoretical error. This is called TA. As per the equation, simple. So percentage of, sorry, kg of O2, this is actual. Say actual. Kg of O2 divided by 0.23. Finish. Now clear, sir? Patel, sir?
Yes, but this actual is this.
Once you do the calculation tomorrow, you can easily understand.
Yes.
This is only you have to understand the basic. Just go through it. Why you are doing one by one? We have to do the calculation. It's a theoretical air.
Okay, sir.
Okay, sir. Now, now you understand theoretical air?
Yes.
Okay, sir. Just we will take 30 seconds, maximum 40 seconds. Okay, sir. I will start with Rajesh, sir. 1 second. It's a very important. This once you whatever understand, then I will take next class as per your review, your understanding. Okay, Rajesh, sir. Tell me, sir, what you understand, sir. Today classes. Simply whatever possible you can just explain. It is enough.
Yeah, sir. In paper 2, chapter 1, it is coming fuels and combustions. What kind of fuels we are using? Mainly coal we are using, natural gas and oil, and some kind of bio natural gas is also there. So in that, what are the physical properties and what are the chemical properties of that fuels? That is important. And what is the GCV and NCV, gross calorific value and net calorific value? So always net calorific value is always less than the GCV. Why? Because it doesn't have consider the latent heat. So moisture content it doesn't have. That formula GCV is equal to NCV plus 584 into 9 times of percentage H2 plus moisture percentage divided by 100. This is crucial formula.
Okay, sir.
So with that we can calculate wherever they given GCV, we can calculate the NCV, and wherever they given NCV, we can calculate the GCV with this formula. That is one thing. And other one, how much they in fuel and coal, natural gas, what is the highest content? Carbon content is how much, hydrogen content is how much, and sulfur content is how much, O2 content is much. That is also important. And 3 types of combustions are there. And one is temperature and turbulent. Temperature means how much temperature is required to get proper heat. Turbulent means proper mixing, how we can mix the that is turbulent. And time,
Shortcut 3T.
sufficient time, 3T.
3T
is very much important for good combustion and perfect combustion, and to analyze the incomplete combustion. So boiler, it is required, input is required, fuel and air is required input. So that will air may have the content of O2 and N2 also. So it will give, this is input 1, and
Yes.
for boiler input 2 will be the feed water. So for input 1, what will be the output of fuel gases is on percentage O2, percentage CO2. This will comes under on volumetric basis. For input, we have to calculate on weight to weight basis, and for fuel gas, we have to calculate on a volume basis, percentage volume basis. And more important is molecular moles and molecular weights. So carbon, how much 1 kg of carbon requires 2.66 kg of O2 to form the 3.66 kgs of CO2.
Carbon.
Like the same by H2 for N2. And now theoretical aid and this exercise. So these we need to practice, sir. That formula, theoretical air formula will comes, as you said, how much amount of air is required on particular material. Suppose carbon, how much content of O2 is required, and sulfur, how much content of O2 is required, and oxygen, how much content of O2 is required. That will give the formula. So that 11.56 into C plus 34.78 into O2 plus 4.34. That 11.56 will comes, as you said, last you said that quantity of the air divided by 0.23.
0.23.
So 1 kg of carbon required 2.66 kgs of O2. So which means 2.66 divided by 0.23. It will give some
Yes.
value. So
We
like
have
that
to
we have to form
add
the
all
equation.
CO2,
Yes.
SO2, H2. How much total O2 required divided by 0.23.
Correct. So that will give the theoretical air calculation.
Yes, that will give the O2. Exactly, calculate O2. Next,
Correct, sir.
we have to calculate actual amounts. We have to minus with whatever the O2 value in fuel.
Correct, sir. Okay. So here one more important point is before boiler burn and after boiler burn. before boiler 1, we need to calculate the theoretical CO2 and
Yes.
theoretical air, and as well as N2H2 and SO2. And the main important formula for CO2 theoretically is number of moles of the carbon divided by total, what are the material like carbon, sulfur, O2, summation of all total molecular weight.
Molecular weight.
So, and after burning, it will give the NO2, CO2, and SO2 and CO2, nitrogen,
Okay,
SO2,
sir.
and CO2.
Super, sir.
So, and
Why this?
oxygen
Yes, sir.
percentage is 23% and nitrogen percentage is 73. This is also important.
Okay, sir.
Yes,
So
sir.
everyone congratulations, Sir Rajesh sir. You wonderfully understand this concept. Paper 2 is
Yeah,
very important because we are starting with you now. So you have to full concept this paper 2. Paper 3 almost we have took all the concept. So paper 2 is a crucial paper, chapter 1, chapter 2.
Correct, sir.
Okay, sir. So Kumar sir, I hope you enjoy the process. So I detailly explained all the concept, how to do the O2 calculation, how to calculate theoretical, and step by step I have explained. So this video almost you understand chapter 1. Next we focus on the calculation. So whatever you are learning, just share our group. It's very important things. And you have to discuss with your community and group. You have to form the group. So before start day 3, you have to form the group. It's very important mandatory. So thank you very much for the passionate attend the whole session. I hope